Math 3, Unit 3, Section 7. Today we're talking about factoring sum and differences of cubes. What is a cube? Yeah, something to the third power. So like x cubed is a cube. So remember how we did differences of squares? Yes? This is a similar idea, Aaron, but you need to have your notes out and take these with us. Oh, okay, sorry. Except for, remember with squares, it was only difference. With cubes, it's sum and difference. So if both terms are cubes, it doesn't matter if it's adding or subtracting, it's going to work. Okay? So there's a couple things, though. I'm gonna do that next. Okay, so there is one thing, one kind of trick for sum of perfect cubes and differences of perfect cubes, and that is using soap. Now, while we hope that all of you use soap daily, we also are going to use it. Some of you maybe need to use it more often than others. No, I'm just kidding. Okay, but so what this soap stands for, okay? It means that your first sign right here, it stays the same as it was in your original problem. So if you notice here how there's a plus sign, in your first parenthesis, the first sign will be the same, okay? Same thing over here. Do you see how this one's a minus? Stays the same. Okay, O, what do you think O is going to stand for if we're looking at our signs? Very good. O stands for opposite. And then this last one, what do you notice about these signs? What are they? They're both what? They're both positive. So this one started as a plus and the end was a positive. This one started as a minus and it ended as a positive. So guess what AP stands for? Close. Always positive. It's a multiple meaning word, I guess. I can't spell positive. Okay, here we go. So, perfect cubes, this is just to help you out as you're going through this process. We're going to write out what each of the perfect cubes are. So, 1 to the third power is 1, 2 to the third is 8, 3 to the third, 4 to the third. Good job. 5 to the third. 6 to the third. Is that where you guys get stuck? Okay, that is 216. 7 to the third is 343. And 8 to the third is 512. Okay. Are you guys ready to learn more about this process? So these are like the formulas for factoring by cubes. Your answers are going to look like this. Okay, and then I'm going to show you so that it makes it like super easy and you don't have to actually remember a formula because you'll actually know how to do it. Okay.
Which ones are answers supposed to look like?
One more time?
I said which one are your answers supposed to look like?
Both of these. So when you're factoring your cubes, once each term is factored as a cube, your answers look like these answers. Okay, here we go. So starting here with this first example, we have 8x to the third plus 125. How can I write these all as cubes? What is 8 as a cube?
2 cubed.
And then we have x cubed, which is already written as a cube, plus, and then how do I write 125 as a cube? Good. Okay, so we always have to start by writing everything as a cube. Okay, the next thing is that you'll notice that these two are together. The 2 cubed and the x cubed, they're in the same spot. Okay, and so what we're going to do is we're going to write this out 3 times. So we're going to keep the 2x together and we're going to write 2x times 2x times 2x. Because those are all to the third power. That's why I wrote it 3 times. And if you have 2 terms like this that are both cubes, you keep those together. Okay, and then I have 3 5s. So I'm going to write times 5 times 5 times 5. Okay, now when you are factoring, and if you go back up here to this problem for just a minute, you will notice that once they're written as cubes, your first parenthesis is the same as it was with the cubes. You just take off the cubes. Okay, do you guys see that? Okay, and so that means what would be my first parenthesis on this one? 2x plus 5 is correct. So all we're doing is taking everything that's there, okay, and we're just taking off the cubes. So it's just kind of like we're eliminating all of those cubes, and we write that as 2x plus 5. Okay, now our second parenthesis, which we can see if you look at the top again, it's much longer. And this is how the second parenthesis works. You group these all by 2's because it makes the 3 terms. So each of those groups makes one of the terms. What is 2x times 2x? 4x squared. I'm going to leave the blank for my sign here for just a minute. My middle number is going to be 2x times 5, which is 10x. And then my last term is going to be 5 times 5, which is 25. Okay, and then this is when we're going to use SOAP. Same sign. This one is the opposite sign, and this one is always positive. And we're done. That's factored as far as it is able to go. What? Can't you multiply 4 times 25? Oh, yes. You could end up using the quadratic formula on this, and actually there's going to be a point when we're going to, but it doesn't factor out into be 2 factors. So 4 times 25 is 100, and if you think about 100, there aren't any numbers that multiply to be 100 that add to be negative 10. So you'd have to use the quadratic formula. Okay? And we actually will do that at one point. Okay, so let's practice factoring by cubes on this next one. So 1,000, that was not one that I wrote down. Very good. 1,000 is 10 to the third power. I'm so glad you guys knew that. So we have 10 to the third power minus w to the third power and y to the third power. So in terms of my multiplying this out, how am I going to write out these? Good. 10 times 10 times 10, because there were just 10s there. But on this one, we're going to write the two things together. And so how will I write that? wy, wy, wy. We don't have to worry about the negative sign right now, because remember, we add that in with the SOAP. Okay? So what will be my first parenthesis? Good, because remember, we're just taking off the cubes for our first parenthesis, and it's just written as 10 minus wy. Okay, my next parenthesis is where we group each of these by 2's. What will be the first term? Good, 100. We'll go ahead and leave the blank and use SOAP after. 10 times wy is 10 wy. And then my last term will be close. You need to write that as w squared and y squared, because you have 2 w's being multiplied, which is w squared, and 2 y's being multiplied together, which is y squared. If you put wy squared, that would just be the y squared, unless you wrote it like this, wy in parentheses squared. But then we don't want a parenthesis within a parenthesis, so am I making any sense? Okay, so you'd end up putting this through, and so you'd still end up with w squared, y squared, so it's easier just to do it way back there. Okay, so now use your SOAP, and first sign is always the same, which is already done. The next one is the opposite, and the last one is always positive. Yes. Very good. Candy for you. Okay, so what do you notice about negative signs as well? How many negative signs are in this answer? 1. How many negative signs are in this answer? 1. So when you're factoring by cubes, another double check. is to make sure that there's only one minus sign. And if you have more than one minus sign, then you probably did something incorrect and you need to go back and check. Okay, are you guys ready to try one on your own? Okay, the only thing I noticed though is, do you guys notice something special in this one? It's a, there's 4 of them. We can just say 4. But I'm like, oh, but I noticed something else. And when we're factoring, there's something we're always supposed to check for first. A GCF. Is there a GCF here? Yeah, what is it? You guys are so intelligent. Okay, so we take out an N, and we're left with what? 216 n to the 3rd plus 1. Good. Okay. So, don't forget this is part of your answer. Okay? But can you guys go now and do this? I think you can. Raise your hand when you get the answer and I'll come by and check. And I might even take a volunteer of somebody that wants to come by and up and do this one.
Everything in the problem has 2 cubes. Remember how we started with it is 1.5 plus a is a cube, and then 1.5 is a cube.
So we pass them even though it doesn't have to?
Yeah, you make it into it. You figure out what is 216 as a cube. Perfect. Oh wait. Hold on. What is this one? Looks good. Good job. Perfect. Oh, don't forget your GCF in front. I'm gonna check those in. What is this? And then so when you are writing this is 6.
I think so. I don't know if I can really.
Okay. Do I have a volunteer, somebody that wants to explain it up there?
This is not right.
It's like half and half.
Yeah, no, I got it.
Okay, nobody? Yeah. Yes. Okay.
What is 6 times 6? There you go.
Okay, I'm going to actually go through this one because there's quite a few of you that didn't get it perfect. Okay, so at this point when you have cubes, in order for you to factor using cubes, every single term in this has to be a cube. Okay, and so how do I rewrite 216 as a cube?
6 cubed.
Good. And so I rewrite that this is 6 cubed, this is n cubed, and then can I write 1 as a cube? Yeah, it's just 1 cubed. I did show you that 1 was a cube right here when I had 1 cubed and I gave the answer of 1. Okay, but thanks for thinking I didn't do it. All right. Anyways, okay. So, next, our first parenthesis, or even before that, do you see how all these are cubes? These are stuck together because they're at the front. And so when I'm writing out my 3 terms, just like on this one when I had the 2x, we write the 2x's together. So that means I'm going to write a 6n together. Okay? And so we're going to write this as 6n times 6n times 6n. And then we're going to write the 3 ones out, and we have 1 times 1 times 1. So there should be 6 terms that you write out that you're multiplying.
Always?
Always. Okay? So when I write my first parenthesis, remember, we just take off the cubes, and my first parenthesis will be what? 6n plus 1. Okay, my second parenthesis, and this is where we group 2 terms together, 2, 2, and 2. So always, each one should have 2, 2, and 2 together, which adds up to be 6. Okay, now you have to multiply these. What is 6n times 6n? 36n squared. Good. What is 6n times 1? 6n. And then what is 1 times 1? 1. And then we use our soap. Same, opposite, always positive. And then I'm forgetting one thing. What needs to go in the front? N. Questions for me? Yes?
Could you put 6n plus 1? Or does it open? Like in the middle?
Right here? Right here?
Yeah.
Instead of just 6n? You have to multiply them together. Yeah, so it should be, because it multiplies to be different terms. Other questions? Just stretching. Okay. All right, let's go ahead and do this next one together. Okay, anything you notice we should check for first? A GCF. Is there a GCF? 2. They're both even numbers, right? There's a GCF of 2. Okay, so we're going to factor out a GCF of 2. And what do I get? Minus. Good. And then we still have m to the 6th. Now we're going to try to write everything as cubes. Okay? So what is 512 as a cube?
8.
Very good. It is 8 to the 3rd power. Minus 27 is what?
3.
And I don't know why I put that one in parentheses. 3 to the 3rd power. Now, how could I write m to the 6th as a 3rd power? So I want m, and I want it to be to the 3rd power, like that. So what number would need to go inside here in order to make that a 6? 2. Good, because we know that powers to powers multiply.
Why are you putting the parentheses around the number?
That's what I said. I don't know why I put a parenthesis around the 8. That was just... The only thing that really needs a parenthesis is the m. Okay, my bad. But it doesn't hurt anything. It's fine. Okay. Is everybody okay with what has happened here? No? Okay. So, what should I do next?
Drop off.
We could write out all the terms? Okay. So, this is 8 to the 3rd, so we're going to write out 8 times 8 times 8. And then, how am I going to write the next set of 3 terms?
3m squared.
Very good. 3m squared times 3m squared times 3m squared. Okay, so it's like you're taking one of each of these things and writing it.
What about your negative?
We've never used that in it. Okay, that's where soap comes in. Okay, and if you wanted to, when you're writing these out, you could cross off all your 3's, and it may make it more visual, like, okay, I need to write 8 3 times and then 3m squared. If you take off those 3's, maybe it makes it look less confusing. And so we know that our first parenthesis now is going to be what?
8 minus 3.
Good, 8 minus 3m squared. Yes? We added it at the end. We can go ahead and add that right now. The GCF needs to go there in front. So either way, you don't want to forget their GCF. Okay, now what am I going to do next? Good, so we kept everything the same. So now we're going to group these by 2's and multiply. Okay, what is 8 times 8? Good. Okay, and then what is 8 times 3m squared? And I shouldn't have written this yet. And then my last one is going to be what?
9m squared. 35.
Good, 9m to the 4th. Sorry for this right there. Okay, so now we're going to get our signs. What sign is going to go here? Opposite. And then here is going to be always positive. Okay, do we have questions? All right, so now we get to put it all together. So much fun. Always. Okay, what is the first thing we should always check for? GCF. Okay, is there a GCF here? Very good. There is an X. So we are going to factor out an X. And what am I left with? X to the third. Good. Plus 343. Okay. Next, what will I do?
Turn everything into cubes.
Very good. We want to write everything as a cube. So we have x cubed. And what is 343 as a cube? Good. Okay, now what? We're going to... Good. We can write out the numbers. And again, if we want to, we can cross out these cubes so it looks less confusing maybe. And we can write, we want 3 x's, so x times x times x. And then 7 times 7 times 7. What is my first parenthesis? Good. X plus 7. And what should we also not forget to write? Very good. Okay. Now, my next parenthesis, we group these by 2's. X times x is x squared. X times 7 is, and 7 times 7 is, and what goes in there? Perfect. Same sign, opposite sign, always positive. Okay, now we know that nothing multiplies to be 49 and adds to be -7. We can use the quadratic formula though when we set this equal to 0. So you know how we have to set each of these factors equal to 0 in order to find how it goes on the graph. Do you guys remember? Okay, so what we're going to do is we are going to set each of these factors equal to 0. So my first one, can x equal 0? Yes, x equals 0. So at the bottom here where it says real zeros, guess what one of my answers is? 0. Okay? And also, just so you know, zeros and roots, sometimes you'll see the word roots. It's the same thing. This also is your x-intercepts, right? So these are 3 different words that mean the same thing. Okay? So up here, we set this equal to 0, and what does x equal? Okay, so that's also a real number, -7. Are we okay there? All right, so now we set this equal to 0, and we can't factor it. So we have to use the what? Quadratic formula, which you should know, but in case you don't, I'm going to write it here for you. And you should go watch the Pop Goes the Weasel song. But x equals -b plus or minus the root of b squared minus all over. You guys are amazing. Great voices. Maybe you should try out for choir next year. Okay, but back to the problem. What are my A, B, and C values? Okay, just the values in front. So A always goes with your x squared term. A is what? What coefficient is front of A? 1. What is B?
7.
Good. And what is C? Awesome. Okay, so now we're going to take that information and we are going to plug it into the quadratic formula and see what happens. Okay, so what would be my -b value using my formula? Very good. 7 plus or minus the square root, and we're going to write b squared, which is -7 squared, minus 4 times A is 1 times C is 49. And then this is all divided by 2 times 1. Okay, I'll stop there for a minute. Does anybody have questions up to this point about the quadratic formula or anything? We've already learned this multiple times throughout our education, but I know we still sometimes get confused, so ask me questions if you have them. Okay, so for me, I like to just simplify everything and try to not have to take up tons of space. Okay, so I cross out -7 squared, and what does that make? 49. Okay, and then I multiply 4 times 1, or -4 times 1, which is -4, and -4 times 49 makes -196. And you can use a calculator if you want to, okay? 49 minus 196 equals, does anybody know?
Negative 147.
Good. Okay, and then we know that 2 times 1 makes 2. Okay, so we rewrite this. It's 7 plus or minus the square root of -147 all divided by 2. What do we know about having negatives under roots?
It's an I.
Very good. It comes out from under the root and becomes an I. Can 147 break down? The answer is no. It's not going to end up working out. So we get 7 plus or minus I root 147 all divided by 2. Is that a real number? No. It's an imaginary 0. And so we are just going to write that answer down here. And how many imaginary zeros are there?
2.
Very good. I'm glad you guys are paying attention. 2 is correct. How are there 2? Because I only wrote one number there. Very good. Plus or minus. There's one answer, so that's a plus, and one that's a minus. Okay, we're going to go ahead and do one more. We'll try to do this one a little bit more quickly. Okay, first thing we're going to do here is what? Write them as, oh yeah, check for GCF. Is there a GCF? Okay, so now we're going to write them as cubes. Good. What is 64? How do I write 64 as a cube?
4.
Very good. 4 cubed minus x cubed. What will my first parenthesis be? Good. 4 minus x. And it doesn't really matter the order we do this in. What should I write out now?
4.
Good. 4 times 4 times 4 times x times x times x. Meaning the order doesn't matter in terms of if we write the parenthesis first or write this out first, right? Okay, now what do I do? Group them in twos. 2, 2, 2. Do we have a question from anybody? Okay. So what is my second parenthesis going to be?
16 plus 4.
Now, normally, I would say we probably should have flipped this around and factored out a -1. Either way, we're going to get the same answer. Since we're not graphing on this one, I'm not as worried about it. I'm not as worried about my leading coefficient. But either way, you'll end up with the same answers at the end. Okay, 4 minus x is going to give me what as an answer? It's going to be 4. Let's say you don't know. So if something's written like this, some of you might need to actually set it equal to 0. 4 minus x equals 0. If I want to make x positive or get x by itself, I might, in this case, go ahead and add x to both sides. And when I do that, I get positive 4 equals x. Okay. So is that a real 0?
Yes.
Yes. So in my real 0 spot down here, I'm going to put a 4. All right. Am I going to be able to factor this one? No, no and yes. No, it doesn't factor nicely, but I can use the quadratic formula. Okay, but I notice that this is not in the correct order. Okay, a always goes with my x squared term, so I'm going to rewrite this in descending order. Okay, x squared plus 4x plus 16. So what is my a value? A is 1, b is 4, and c is 16. So when we are solving this one using our quadratic formula, what will be my negative b value? Negative 4 plus or minus the square root of, good, 4 squared minus 4 times 1 times 16, all divided by okay. What is 4 squared? Okay, and then 4 times 1 times 16 is? It's 64.
Yeah, it is. Yeah, it is.
Okay, and what is 16 minus 64? Negative 48. Some of you might want to use a calculator. Okay, and then 2 times 1 makes 2. Okay, so we go back here. Negative 4 plus or minus the square root of negative 48, all divided by 2. What will I do next? Good. So we get negative 4 plus or minus I root 48 all over 2. We're going to go ahead and break down 48. What two numbers multiply to be 48?
16.
Good. 6 and 8. And then we know that 6 is actually good. And then 8 I know is 2 times 2 times 2. So instead of going 4 and 2 and then 2 and 2, I know that 8 is 3 2s. Okay, so we need groups of 2 because this is a square root. So I have 2 2s, another 2 2s, and a 3. How will I write that? So we still have negative 4 plus or minus, and then when I bring these out, we multiply those together, good, and you get 4i. Because you have one group of 2's, which brings out a 2. You have another group of 2's, which brings out a 2. And then we're left over with root 3 all over 2. And last thing is, could that reduce at all?
Yes.
All of them can reduce by 2. But it only works if each of these outside numbers are divisible, right? In this case, they are. And so when I reduce each of them by 2, this one becomes a 1, this becomes a 2, this becomes a 2. So my answer ends up being negative 2 plus or minus 2i root 3. And actually 147 could have broken down, but we're just going to leave it the way it is right now. Okay. All right. Any questions?